Hey guys, welcome to this session. Our topic is current, this thermocurrent electricity. Today let's discuss about the resistance to the electric current. So here we're going to discuss this resistance. So we'll start with the concept of resistance. Uh, let's see the resistance of a wire. Resistance, simply we said that is an opposition to flow of current. So here we're going to see this resistance of wire, just or a resistance of a conductor. Now let's dive into it. The resistance of a wire, basically this depends on the length, that is can be denoted as capital L, and the cross-sectional area of the conductor, that is can be denoted as capital A. Now from there, you see that R is direct proportional to the L. Now also from there, you can say that R equals to L divided by A. That simply means that the length of the wire divided by the cross-sectional area. Now if you combine these two, that is the first equation, that is R is direct proportion to L, that is the resistance of the wire is direct proportion to L, that is the length of the wire. Then and the second one that is generated from there, that is R is equal to K multiplied by L over A. Simply that is resistance is equal to the constant, then multiplied by the length of the wire, then you divide by the cross-sectional area. Now from there, the K is the constant called the resistivity, denoted by capital J. So from there you can say that R is equal to J multiplied by R upon A. Now if you factorize or make J the subject, J will be equal to R times A upon L. So simply from all this, we get that resistivity, that is J, is the resistance of a 1 meter length of a piece of a conductor or a wire whose cross-sectional area is equal to 1 meter square. So from there, you can get the definition of resistivity by the formula that we have derived above. So resistivity, this is just the resistance of 1 meter of the length of a piece of a conductor or a wire, whereby its cross-sectional area is equal to just 1 meter square. Now, from there, let's see an example that is related to what we've discussed. Take an example. The resistance of a copper wire is found to be 10 ohms. Now, we are required to calculate the resistance of a copper wire of the same length, but whose radius is twice that of the first wire. So, solution, we will let that R and J be the radius length, and just R is the length or radius, and the resistivity of the wire, that is J, whose resistance is just 10 ohms. Now from there, so R will be equal to J times L upon A. But we can say that cross-sectional area, we are talking about the cross-sectional area of a wire. We can obtain it from the formula, that is pi d square over 4, or just pi r square. So R will be equal to A L divided by A, that is the cross-sectional area. Now you let that is 2 R, that is two radius that make up a diameter, L, that is just the length, and J, that is the resistivity. So you let it to R, L, and J be the radius, length, and the resistivity of the wire of the resistance R respectively. So from there you can say that R equals to J L divided by the pi 2 pi r square. Now, if we divide these two equations that we are talking about equation 1, we are talking about equation 2 divided by equation 1. Now, from there, if you substitute the value of resistivity, that is 10 ohms, so from there you get that this pi r square will be cancelled out. So will remain like this: pi I mean r upon 10 ohms equals to jr upon pi r square, and that is 1 over 4. So pi upon 10 ohms is equal to 1 over 4. So from there, if you are trying to find the value of r, it means that you cross multiplication and later on the value of r will get 2.5. So simply just the resistance of a conductor is 2.5. So you can follow up this, how we've done this example, just to see how the formula that we discussed before, how it has been applied from our example. So I hope it's clear. Thank you for listening, guys. We've just briefly discussed about this, the resistance of a wire. We've seen how we can obtain a resistivity of a wire, and we've discussed the one example of this kind of a concept. Thank you.